Hi, this video explains how the direct impacts are calculated within the INDRA model. For more information, please consult the Deliverable 2.3 Coastal Risk Assessment Framework guidance document available on the RISC-KIt website. In this video, we will learn how the hazard and the receptor information are imported in INDRA, as well as the vulnerability indicators information, and how they are associated to estimate the direct impact. Direct impacts are calculated for all receptors using the same approach. We are considering 4 thresholds of vulnerability leading to 5 levels of impact, classified from no impact to very high impact. To do the calculation, we have to consider a hazard intensity value, a receptor location, and a receptor vulnerability indicator, which is based on the vulnerability library information. As you can see here on this little figure, the hazard intensity value is derived from the hazard map provided in a shapefiles format. The receptor information is provided by a land use map also in a shapefile format. And the vulnerability indicators is provided within a text file called CHT for INDRA. 3 types of hazard are considered in the model: flood, overwash, or erosion. They are all provided using a polygon shapefiles. You will have the option to consider only 1 hazard or up to 3 hazards within the model. For flood and overwash, specific information are required with the polygon shapefile. Information on the flood depth, on the flood depth velocity, on the flood duration expressed in days, and on the wave height. This information should be calculated outside the INDRA model using flood models, or using expertise if specific intensity can be calculated using the flood model. The erosion is simply represented by a polygon indicating the sea domain. The outline indicates to the model where is the shoreline. The land use information is imported using a point shapefile. A point can represent a specific property type, such as a 1-story house, a restaurant, a field of grassland, or a more generic type of receptor, such as a residential property or a business. But a point can also represent a group of properties, either generic or specific type. For instance, 5,000 residential properties or 1,000 one-story houses. Here you have an example of the table of the shapefile with specific fields that will have to be filled. So you will need a unique reference value, a vulnerability land use code, the number of assets associated with the point, could be any number, the elevation of the land use compared to the ground level in meter, the area associated surface, and NAT area, which is the vulnerability of the area, in particular for the risk to life calculation. Finally, you need to provide information on the vulnerability indicator. This information is included in the CHT for INDRA text file. The file provides the 4 threshold value used to calculate the level of impact. for a specific receptor type and a specific hazard intensity. So the first information you have to provide is a code indicating which receptor should be considered and a code for the hazard intensity type. You can see here for a property we use the code prop, and for float depth we use FD, for float depth velocity FDV. Then you have to give a value for the 4 thresholds. If a threshold is not considered because a specific level of impact is not expected, a value of 9999 has to be used. If we take the example of float depth leading to specific damage, in terms of impact, we are considering 3 out of 4 level of impact. A low impact, representative of minor damage to the property, where mainly drying and cleaning will be required. A medium impact, where more household inventory items are damaged and the building fabric also is severely damaged. And a high level of impact, where the foundation can be undermined and we can have some partial building collapse. The very high impact in this case is not considered, as float depth may not lead to a building collapse situation. Therefore, a 9999 value is used. To develop your damage thresholds, you will have to consult the vulnerability library where existing depth damage curves are provided, and ask yourself if this data is representative of your case study. You will also have to investigate the variability within the building types in your area, and if you can use an average damage curve or if you need to use specific damage curve. If none of the existing depth damage curve are suitable for your case study, you will have to develop your own threshold value, either using an empirical approach based on existing data from past floods or using an ex-ante approach. Ex-ante approach consists in visiting the site and develop the threshold based on reasoning and judgment. Another direct impact that can be considered in the model is the situation of building collapse due to high float depth velocity. In this case, you can refer to the building collapse matrix available in the vulnerability library that indicates for different house type the threshold of depth velocity leading to a partial or a total collapse. You can notice here that in this case we are not considering low and medium impact when considering the depth velocity product. To calculate the erosion, you will need the position of the shoreline, which is provided by the erosion map, the position of the receptor type, provided by the land use map, and the model will calculate the distance between these two. The vulnerability indicator for erosion is based on the distance threshold between the property and the shoreline. 3 levels of impacts are considered: a low impact, representing of a disruption of the activities before and during the event for safety reasons; a medium impact, where post-monitoring thresholds are needed in the aftermath of the event; and a very high impact, where we have a collapse of the property. For the risk to life, the risk to life matrix has to be used. You will need 2 types of information on the depth velocity provided by your hazard map, and you will have to inform the model on the nature of the area. As an example Coming from the vulnerability library, 3 levels of vulnerability are associated with the nature of the area. The highest vulnerability being applicable for sites such as campsites, or the presence of mobile homes, bungalows, or poorly constructed properties. For ecosystems, the model calculates their potential recovery using the PHYSIUS EU project approach. The model estimates the level of change within an ecosystem, the worst-case situation being a permanent effect leading to a change in the type of ecosystem. Within the library, you will find information on the different threshold values and hazard intensity to consider for specific ecosystem.